All right, today we are doing section 1.8, which is called the finite differences and polynomial sequences. So in launch task A, it says predict the next two terms in the sequence. So you should be able to tell that they're increasing by 4. So the next term would be 23 and then 27. This would be arithmetic because it has a common difference. To do the explicit formula, so let's not forget what we did earlier in the unit. A sub n is going to be -1 plus 4 times n minus 1. Now when it says find the recursive formula, it's 2 parts. You state the first term, and then what are you doing? You're taking the previous term plus 4. All right, then launch task B. It says find the first 4 terms of this sequence. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. Then it says find the first 5 terms of n cubed. So that's 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. Let's take a look then at what we just did from these 3. And you remember, these all had a common difference of 4. And so this was the first difference. So we call it linear. Let's look at the second one in launch task B. So this has a common difference when you get to the second difference, and it's quadratic. Then here I go up by 19. I go up by 37. And then 61. So then that is 12. This is 18. And 24. And so this actually takes a third difference before we get to a constant. So it is a cubic function. So you may recall from geometry the famous handshake problem. It went a little something like this. Each of the 30 people at a party shook hands with everyone else. How many handshakes were there all together? Well, if you had one person, there would be no handshakes. 2 people would be 1. If you had 3 people, there is actually a total of 3. So think about who you would shake hands with, and the order wouldn't matter. Now that you're in pre-calculus and are an Algebra 2 graduate, you were able to do the method of finite differences in order to discover that the relationship was quadratic. So if you remember, we would use y equals ax squared plus bx plus c. And then if you looked at these as ordered pairs, I can go plug these in as the x and the y. And what this does is it produces a system of equations. So if you remember, you would do this on your graphing calculators. And then here was the equation. So what we're going to do together is I'm going to do 2 examples. One, I'm going to refresh your memory on using the graphing calculator. And then on example B, I'm going to show you a regression method that Desmos will do. So this says, consider the equation. So I'm going to sort of make a table here. The first value is -1. The second term is 2. The third term is 7. The fourth term is 14. The fifth term is 23. And the sixth term is 34. So if you did the difference, oops, sorry, it's 5, 7. And so you can just verify that that is in fact quadratic. So then what you're going to do is we're going to use y equals ax squared plus bx plus c, and we're going to take the first point. So that means I plug in y is -1, then this is a plus b plus c. If I plug in 2, 2, that's 4a plus 2b plus 1c. 3, 7 is going to be 7 is 9a plus 3b plus c. So what you're going to do is you're going to need to enter a 3 by 3 matrix, find its inverse, and then you multiply by the 3 by 1. And when you do that, it'll spit out 1, 0, -2. What that means is A is 1, B is 0, and C is -2. So because I am using Q sub n, I'm going to just change the letters a teeny tiny bit here. So this would be Q sub n is n squared minus 2. All right, just make sure if you don't remember how to get matrices on a graphing calculator that you see me gold period, ask me in class, get to math lab, see me before school. All right, so now with this particular one, what we're going to do is the first term is -2, the second term is 1, the third term is -4, the fourth term is -5, the fifth term is 10, and the sixth term is 53. All right, so I'm going to try this here. So what we're going to do is we are going to go to Desmos, and I'm going to hit the plus sign and create a table. So then what you're going to do is you are just going to enter these values. And then it is really, really neat what happens here. Now, it did say in the problem that this was cubic. If you didn't know that, you would need to do the finite differences. Whoops, sorry. All right, then what you're going to do is you're going to go back up to this top left button, and it says regression, and it says cubic. And then do you see the equation? Y equals 2x cubed minus 16x squared plus 37x minus 25. So it is fabulous that Desmos will do that. Now they're having me use C sub n, so I am going to use n instead of an x, okay? So you hit the plus sign, creates the table, and then you do that wiggle, and that does regression. And in this one, you choose cubic. All right, if you want to try this one, I'm not going to work it out, but if you try it, here's what you should get if you, whichever method you choose.